Good morning everyone. This is Swapna. Today we are going to learn about the find has algorithm. That means finding a maximally specific hypothesis. Finding a maximally specific hypothesis. To find that one, here they gave the algorithm. Algorithm means which is gives the as a step-by-step procedure. What is the step-by-step procedure is initialize the H to the most specific hypothesis in capital H for each positive training instance X for each attribute. Within that, once again second step continuing for each attribute constraint AI means attribute, constraints means attribute constraint in H. If the constraint AI is satisfied by X, then do nothing else, replace that with the next more general constraints that is satisfied by the X. Last step is we are getting the output hypothesis. What we are getting the output hypothesis? Maximally specific hypothesis. So this is the algorithm given here for find S algorithm. This is the steps present in the algorithm. So to understand this, here we are using the some terms, that is specific hypothesis and general hypothesis. Most specific hypothesis will contains the hypothesis will contains the all the null values, and more general hypothesis will contains the all the question marks in place of attributes. And depending upon our example, how many attributes you are taking, that many null values contains in that specific hypothesis, and depending upon how many attributes you are considering for every instance in our example, depending upon that many question marks are present in the general hypothesis. So most specific hypothesis will contains the all the null values that is related to specific. Most general hypothesis will represent with the all the question marks, that many number of attributes which present in the instance. Already we know about the instance. And what is hypothesis? Instance is one particular training example we are taking, that we can call as a instance. It is a conjunction of some attributes, and H is a specific hypothesis. Capital H, already we know these are the set of hypothesis, and capital X is set of instances. So to understand this, here also we are considering the one more example, enjoying sports example only, and in that we are having the 4 instances as well as some hypothesis. So to find the maximally specific hypothesis, we need to follow the algorithm, that is step-by-step procedure. What is the first step-by-step procedure? In step-by-step procedure, find S algorithm is, what is the first step means, here we are specifying the first step of find S is to initialize the hypothesis to the most specific hypothesis in set of hypothesis, that is so this one is the example we are taking, that is what is the example. Here also we are considering enjoying the sports only. For this, number of instances we are taking is 4 instances, x1, x2, x3 and x4 instances. And what is the target concept? Concept or target value of these specific instances are represented with the plus and minus symbol. Plus symbol means positive. Plus symbol means this is the positive training example. X2 is also represented with the beside plus symbol. That means this is also positive training example. X3 is the negative training example. X4 is the positive training examples. And whatever the hypothesis we are going to get to find the maximally specific hypothesis, these are the step-by-step hypothesis. For pictorial representation, here left box is represented with the capital X means set of instances. Here we are represented the x1's hypothesis, which is the positive training example. X2 is positive training example instance, H3 is negative training example instance, and X4 is positive training examples. By that we will start with the H0. H0 is the more specific. Next, by the end, like this arrow mark, we are finding last specific hypothesis, which is more general hypothesis. From specific to, we will make it as a more general one. That only we are finding. by using this step by step procedure. So that for that purpose, what is the first step? It is first write the most specific hypothesis. So till now only I said what is most specific hypothesis means which is having the more null values, that is how many attributes are there, that many null values conjunction statement we can call as a most specific hypothesis. So we are starting with the H naught. H naught will contains the most specific hypothesis with it is represented with the all the null values. In these instances, how many attributes we are considering? 1, 2, 3, 4, 5, 6. That's why most specific hypothesis is the conjunction of these attribute values of null. 1, 2, 3, 4, 5, 6. So this one. So second step. What is the second step in this algorithm? Find S algorithm means see this one. Go for each positive training instance. For each positive training instance, go for each attribute constraints. Go for each attribute constraint. First go for the positive training instance. Within that, go for the each attribute constraints. If the constraint is satisfying the whatever the constraint is satisfying the x, then do nothing. Don't replace. If it is not satisfying, then replace with the more general constraints. That is the second step. So now we are going for the first step. We are completed. H naught is having the most specific hypothesis, which is having the values of all the null values for every attribute. Next step, second step, we are continuing with this example. So for this example, second step is H1. Second step is H1. That is, we are replacing all the null values with some constraint possible values to make it as little bit general. To make it as little bit general, here null value it doesn't accept any value. That we are representing with the same thing, whatever the first instance is there, x1 instance, by that values we are replacing the hypothesis. That is, all the null values are replaced by the first instance attribute values like sunny, warm, normal, strong, warm, safe. So we are replaced with these values. Is that clear? So second step, we are started with the positive example. X1 is the positive example. That's why most specific hypothesis H naught is replaced by H1. Whatever the attribute constraint values are that are specified in this. So this one only the so here in this slide we are specifying H naught. We are considering the most specific hypothesis. After that, according to the step 1, this one is completed. According to the step 2, we replaced H naught with the x1 attribute values sunny, warm, normal and strong, warm. So now according to the algorithm, we entered into the step 2. We are started with the positive training example. After that, we need to consider every attribute with the instance. So compare with this. Every attribute with the instance. So H naught is replaced by the x1. Next we are going for the every attribute we are replaced with this. So next within the second step we need to go for the one more positive example. That is the x2. X2 is the second positive example. So we took the second positive example and we are comparing each attribute with this x2 instance with the h1 attribute, and we are, if they are having the same value, no need of replacing, we need to keep that as it is. So now we are finding the h2. From by comparing with the x2 with the h1, by comparing with the x2, second positive example with the hypothesis attribute, each attribute value. Here see, x2 first attribute value is sunny. This one is also sunny. That's why we are writing as it is as the sunny, do nothing. And second attribute warm, here also warm is there. We are writing as it is, no need of writing. Third one is the high, here it is a normal. Here it is a high. This one is the positive example. So replace this value with the more general. Replacing the third attribute value with the more general means what is the general? To identify as a general hypothesis, we are replacing with the question mark. Clear? Next we are going for the fourth attribute. Fourth attribute is here value is strong, here also value is strong. So that's what we are writing the as it is, strong. Next we are going for the fifth attribute, warm, warm. So we are writing as it is as a warm. So x2, same, same. Last attribute is also same, same. So that's what we are completed first step, most specific. Within the second step, with the first training example, we wrote this H1. Next, within that second step only, going for the next positive example, that is x2, and comparing with this H1, and we found that by replacing the one attribute value, third attribute value with the more general one question mark, we got now H2. We got now H2 hypothesis. We got now H2 hypothesis. That's what here we are specified in this first step, second step, first positive example. By the second steps, with the second positive example of comparison of each attribute, we got this type of hypothesis, which is having the attribute values sunny, warm, question mark, strong, warm, and safe, like this. Next, within that second step only, loop will continue. For word represents the loop condition. Loop will continue till that step continues. So we are going for the next one. Third, what is the third instance? Third instance is represented with the negative symbol, minus symbol. That means this one is the negative example. In find S algorithm, we need to consider only the positive training examples. We are ignoring the negative examples. Whenever we are in the sequence, we are getting the negative example, we are writing the same hypothesis as it is. Nothing we are considering, nothing we are comparing. We are ignoring that negative example as it is, and we are writing next step of the hypothesis, finding that as it is. That's why x3 is the negative example. So from H2 we are writing H3 as it is. H3 as it is. We are ignoring the third instances because third instance is negative. Third instance is negative. C. So the current hypothesis is negative. That's why we are not writing. We are not neglecting that one, and H3 we are continuing with the same attribute values like this. Same attribute values like this. Is that clear? Next, one more instance is there in this our example. Fourth instance is positive only. So positive training example only. So we need to continue till all the instances. We need to continue with the step 2. What is the step 2? This one only. Once again, for all the instances, till all the instances, and consider each positive training example. After that, each attribute. In that attribute also, if you are having the same value, do nothing. Otherwise, go for the more general constraint. More general constraint means question mark. So till. So we are having in this example 4 instances only. So last instance we are considering with the hypothesis, and we are getting the more general one. So fourth one, x4, and x3 is this is the hypothesis statement. Here also we took that first in the second step, first statement is consider the positive example. After that, compare with the each attribute. So here x4 first attribute value is sunny, and here also sunny. That's why we are writing in the next hypothesis sunny. Attribute value is same only. Warm, warm. We are having the same. Do nothing, write as it is. Warm. Third attribute value is high, and here we are having the question mark. That is more general one only. So anyway, we need to write the more general one only. So that's why we are writing as it is question mark. Next attribute value is strong. Here also strong. So we are writing as it is strong. Next, fifth attribute value is here cool, here warm. So if there are different, then replace this one with the more general one. What is more general one? Question mark. So that is I replaced it with this question mark, this attribute value. Last attribute value is here change, here same. Here change and here same. That's why I am replacing that one same with the once again with the more general one. That is we are getting here question mark. Here no more positive training examples. No more positive training examples. Whatever the hypothesis we are getting, this one become as a output hypothesis. That's what only the last step in the find S algorithm. This one, that one only. So we are completed this loop, we are exited from this second step, we entered into the third step. Whatever the hypothesis we got, that one only the our output hypothesis. What is our output hypothesis here? H4. What are the attribute values it is containing? Sunny, warm, question mark, strong, question mark, and question mark. So this is our output hypothesis. So in this slide we are having the first step within the second step with the first training example, and this one is with the second training example. After this, in this slide we are having with the third training example. Third training example is negative example, that's why we are continued with the same attribute values within the third step with third hypothesis. Next we got the fourth hypothesis. This is the final output which are compared with the fourth instance. By that the four instances are completed for according to our example, and this one is the our output hypothesis, that is we are specified in this slide. So next one. So here what is the example we took? Enjoy the sport. And what we got? We got the output hypothesis by considering the positive training examples only, and final hypothesis will also be consistent with the negative example provided the correct target concept it contained in this one. And so here in this we are considering find S algorithm considering only the positive training examples. And what are the two more words we are using? New words are most specific hypothesis, most general hypothesis. Most specific hypothesis will contain the all the null values. Is that clear? And what are the limitations of the find S? Next we are going to study about the what are the limitations of the find S. What are the limitations of the find S means here we have specified that one. Has the learner converged the correct target concept? So whatever the training examples within that, by that if you got that correct hypothesis only with the target concept, that is whatever the S is there, target concept, positive training examples, that's what. So that is the question mark we are getting, that is only the we are having the doubt, is that whatever the hypothesis we got, is that a correct hypothesis or a more general hypothesis for the training examples, is that is only the doubt. And next one is why prefer the most specific hypothesis. Most specific hypothesis will contain all the null values. In our instances there is nothing like that null value, that is every attribute has the some possible value. There is no training example which will not accept the any of the attributes. But why are we are preferring that most specific hypothesis, and why we are starting with this most specific hypothesis only? That is also it doesn't have the answer. So this is also one more limitation. Third limitation is, are the training examples are consistent, or for this instance till now we took that 4 instances x1 to x4, is that consist, or sometimes we can improve we can increase the number of training examples also. And some training examples, whatever the training examples we are giving, it may has some errors or some noises. Then whatever the output we are getting, is it right or not? That may be sometimes it by depending upon the errors it may represent as a negative example. Generally in find S algorithm we are ignoring the negative examples, we are not continuing with that. Is that whatever the output we got, is it correct? So that is also we are having the out. That is, are the training examples are consistent, are correct training examples only, is that they are having the errors, or they will increase the number of training examples. Then also we will get this one only or not. That is also one type of limitation. And last limitation is, what if there are several maximally specific consistent hypotheses are there? Several maximally specific consistent hypotheses are there. Till now whatever the example we take, within that there is no null values is there. If any training examples examples are there, within that if null values are there and maximum training examples are having the null values and negative examples, then we are getting correct hypothesis only, output hypothesis by using the find s algorithm. For this also there is no answer. So these are the limitations of the find s algorithms. So by this I am concluding this by this I am concluding this topic here. Thank you.